Path tree optimization in discrete partially observable environments using rapidly exploring belief space graphs. This paper presents a new approach to path planning for problems where critical and discrete aspects of the environment are partially observable. For example, the mobile robot at the bottom right on the map has to reach its goal indicated in green on the top left of the map. The status of the doors, open or closed, are uncertain and only partially observable. In this other example, the robot has to fetch an object, but it doesn't know beforehand on which shelf the object is. In such environments, path planning can't be addressed with traditional methods that typically assume that the environment is known at planning time. Our approach is to plan tree-like paths that we call path trees. Path trees are policies that react to observations. We see here an example. In this environment, the status of the door becomes observable once the robot is close enough. The planned path tree first goes towards the door to observe it, and based on the observation, the robot will either pass through the door or rather take the longer route to the left if the door happens to be closed. Here is another example where the robot has to fetch a block. The robot first moves to observe the first shelf. If the robot finds the block, it will execute the corresponding planned contingency and go to the shelf to pick up the block. Otherwise, the robot moves towards the second shelf. The robot will eventually go to the last shelf if the object hasn't been found so far. In this example, there is an opening in the wall that makes an observation possible. The robot first moves to take a look through the opening, and based on where the object is located, the robot will take the left or right branch of the path tree.